Okay, so here we have a question from October-November 2018, paper 4, variant 3. This is question 2. The student asked for part 2, part C. I'll do 2, part B and C because they're kind of related in a way in terms of the method used. Now, part B says the population of a city is increasing exponentially at a rate of 2% each year. The population is now 256,000. Calculate the population after 30 years. Give your answer correct to the nearest 1,000. Okay, so this is a case of compound increase, compound growth, exponential growth. Okay, and there's a couple of methods that you could use to do this. One of them is just by using a formula that's memorized, and the other one is by actually using a method where you think about what's going on. Now, it's an increase, so it's going up, okay, at a rate of 2% each year. So it's like it was 100% and 2% more, so it's 102%, which is as a decimal 1.02. So that's called the multiplying factor. Now the original population is 256,000. Okay, that's going to increase by 2%. So you put times 1.02, but not just once, 30 times. Every year it's going to increase. Okay, and then the next year is going to be 2% more than it was the last year, and then 2% more than it was the last year, altogether 30 times. So if you think about what you're going to have to do, is you're going to have to multiply this by, this is how much it's going to be at the end of the first year, and then you multiply this again by 1.02 for the second year, and 1.02 for the third year. You'll end up with 30 times you're going to have to be multiplying this, okay, by 1.02. So you end up with multiplying by 1.02 to the power of 30, basically. Okay, and that will give you your answer. Okay, so you have 256,000 times 1.0, it's a bit bigger, so what's going on, times 1.02 to the power of 30. Okay, that gives you 463,708. 463,708.56.5655, whatever. Now, they want us to round this to the nearest 1,000. Okay, so that's 463,000. So these are the thousands. Okay, this position is the thousands. This is units, tens, hundreds, thousands. So the nearest 1,000, now 463,700 and something, is closer to 464,000 than it is to 463,000. Okay, you go to the place of the thousands and you see what the number after it is. If it's 5 or more, this increases to a 4, and then you fill in the rest of the spaces until the decimal point with zeros, and you don't put anything after the decimal point. The same. 464,000. So that's the answer. 464,000. There's also another method by some people use by just memorizing a formula. So they say the new value is equal to the original value times 1 plus the rate of increase over 100 to the power of the number of times it increases. It's basically the same thing that we've done here. That's basically how you find the multiplying factor. Okay, so the new value is equal to the original value, which is 256,000. Okay, times 1 plus the rate, which is 2 over 100. This is what gives us as 1.02 basically here, to the power of n, which is the number of years that increases, which is 30. Okay, if it says increase, this says 1 plus. If it says decrease, it will be 1 minus here. Okay, that will make the value get less. And of course, that will give you exactly the same value. I'll just illustrate that for you. So you have 256,000, okay, times, and you got 1 plus 2 over 100, close the bracket, to the power of 30. That should give you exactly the same value, 463,708. Okay, with exactly what we got before, and then we rounded it to the nearest 1,000. Okay, all right, so for part C, we're going to have to use a similar type of concept, except we have something else that's unknown. A bacteria population increases exponentially at a rate of R% each day. After 32 days, the population has increased by increased by 309%. Okay, now this is very important. A lot of people make mistakes like this, or from this. Increased by 309%. Find the value of R. So if we go back to the formula, we know that the new value, okay, is equal to the original value, okay, times 1 plus R over 100 to the power of n. Okay, so what we could say is, let's call the original value, so when it says increased by 309%, that means it's 100% plus 309%. Okay, so that's 409%. That's the new value, is 409% of what it was. Okay, so you can say that the new value, alright, so we could say, let's say the original value was x. You did 1 plus, and R was, we don't know, we have to find R over 100 to the power of 32 is equal to, let me write that a bit clearer. Okay, so x was increased, okay, by R% 32 times, 32 days. Okay, and that gives us the new value, which is basically increasing x by 309%. So it's going to be 4.09 times itself. Okay, so this value is going to equal 4.09 times x. It's going to increase by 309%, so it's now going to be 409% of what it was, which gives you 4.09. Okay, so now the x's will cancel, of course. Divide both sides by x, and we've got to solve this, make R the subject. So the first thing I've got to do is find the root of the 32nd root of 4.09. So let me just write this without the brackets. I don't need the brackets once I found the root. Just like if you had 1 R over 100 squared, you'd find the square root. If it was cubed, you'd find the cube root. To the power 4, you'd find the fourth root. This is the power 32. I want to get rid of that power because I want to find what R is. I have to release that from this bracket. So I have to take the root of whatever's over there. So that's the root, the 32nd root, you could say, of 4.09. Okay, now what will that give us? We have the 32nd root of 4.09. Okay, that gives us 1.4500. Let me just store that in case I need to bring up again. So that's 1.045, lots of zeros. So 1 plus R over 100 equals 1.045, and then some zeros there. Okay, and is that right? 1.045, yes. So then we're going to find what R is. So R over 100 is equal to 1.045 minus 1, which is 0.045. And we've got to multiply this by 100. Okay, if you multiply it by 100, we'll end up with R is equal to, you have to move the decimal point 2 spaces, 4.500 going on. So it's asked us to find the rate, the value of R. Okay, so it's 4.50. Okay, you should write the 0 because it's not an exact value. It continues on, there's numbers at the end. So the rate is 4.50, and that's the answer to this question. Okay, so it's using that same formula that we used above, okay, to solve this problem. Okay, the formula for compound increase or exponential increase or decrease. Okay, so there we have the answer to that question.